Good afternoon, guys. This is Bharat, and welcome to my session of Mission Gate 2022 Electrical Engineering. And in the previous lectures, we have discussed about how to approach the problems that might appear in Gate 2022 through the syllabus that is given in the examination, and through every topic we are trying to cover the types of questions that we might expect in the final Gate examination 2022. So previously we have talked about power systems and power electronics. In this session, we'll discuss about analog electronics. So analog electronics, what we electrical engineering think is, it's not our core subject, and sometimes we give less emphasis on analog electronics topic, and we tend to leave this topic for gate examination. But in the recent years, as you can see, the number of questions from analog electronics has been increasing. It's not drastic, or the rise is not very high, but still it is it has an amount of questions, or the number of marks are such that you cannot leave this chapter saying that it's not our core electrical subject. And also, but though the syllabus is vast, the questions are simpler. Since it is not our core subject, the questions tend to be simpler in nature. In the recent years, the total number of marks from this subject has increased to 6 to 8 marks. If you include digital electronics into it, the total weightage will be around 8 to 10 marks. So let's get into the topic. And in this topic, we'll discuss about what are the different types of questions that you might expect from this subject, and what are the topics you need not prepare even though they were given in the gate syllabus. So a bit about myself. I am Bharat. I am Bharatchandra. I have done my graduation from IIT Bhubaneswar. I have passed out from 2015. Uh, I secured a rank of 46 in GATE 2021 All India wide, and a rank of 39 in Engineering Services Examination, Electrical Engineering Department in 2020. Through GATE 2016, where I have scored rank of 336, I got selected into IOCL and Power Grid Corporation and IASC. I chose to go to IOC, where I worked for 3.5 years. In 2019, I secured a rank of 37 in AP Transco examination. So this is a bit about myself, and this is our Telegram channel where you can join to discuss doubt with topmost educators on this platform. The link is given in the description. That is https is to /t.me/creatrix gate ee. Topmost educators will be available in this group, so that you can discuss doubts with your colleagues, and the doubts with the educators in this group. Unacademy is conducting all India mock tests every weekend on every Sunday. So there were two tests that were held on Jan 2nd and Jan 9th. So if you have missed out on those two tests, you still have a chance to enroll for the upcoming tests, which are going to be held on 16th, Jan 16th, 23rd, and Jan 30th. So if the participation in these examinations is more, then you will get a clear idea of how it is going to be in the final examination. These mock tests are curated by topmost educators on this Unacademy platform who have topped gate examinations previously. And also the analysis of these mock tests will give you an idea of how it is going to be in the final examination, how the competition is going to be, and how the questions are going to be in the final exam, so that you will have a clear-cut idea of how to approach the final examination. So the QR code is given, and you can click on the QR code to join the test series. And you have access to unlimited access to the courses that are available for you. And there are rank improvement batches for those who could not convert the examination previously and who have missed it by a narrow margin. And also crash courses are for those who don't have much time for the upcoming examination, and who think they can be placed in fast track. They can make use of these crash courses. And coming to Unacademy Iconic, there you will be having a personal coach who will be giving one-on-one guidance to you throughout the examination preparation, and also he will be giving strategies to you. and you have a dedicated doubt clearing educators here, and the notes that is giving to you is specialized by the educator that is assigned to you. We'll be having study planners and study booster sessions and in-depth analysis of the tests that you are taking on this platform. So this will be helpful for you in the upcoming final examination. So with the analysis, with the in-depth analysis of whatever tests that are conducted on Unacademy platform, you'll know how to approach for the final examination. So this is about Unacademy Plus and Iconic and the features. And now coming to the subscription charges. So here you have to pay 2,704 per month for Unacademy Plus for 12 months course. At the time of checkout, don't forget to use my code KBC10 for extra 10% discount. And if you take Unacademy Iconic subscription, you need to pay 4,704 per month for 12-month course and 3,467 per month for 24-month course. So you need to use my code KBC10 for extra 10% discount. As I have told you earlier, this is coming with a live mentoring product. This is coming with Unacademy Iconic, where you will be having a one-on-one live mentoring with Iconic subscription. So you'll be given a mentor who will be in charge of all your progress, and he will track your test records. He will analyze your tests, and he will give you your personalized notes and everything. So at the time of checkout, use my code KBC10 for extra 10% discount for Unacademy Iconic. So this is about Unacademy special class. So this whatever I'm teaching you now is on YouTube. Whatever topics I could not discuss now, I will be discussing them on special class. So the link for special class will be given in the description if I am going to take any. So please attend the special class to know about the topics that I have missed. I'm going to know the topics that I cannot cover now. So the special class will be more interactive and more fun than whatever we are doing on YouTube now, because those classes will be more interactive and more fun. We can create polls for the students that are listening to the class, and you can use the help of raise a hand uh, in the class, so that you can ask a doubt, and you can rectify your doubts in the class itself, and you will be getting notifications if you have subscribed to my channel on Academy. And at the end of lecture, you will be getting lecture notes, so that you need not take any special notes during the class, and you can attend these classes anytime, anywhere, because these are all internet based classes, and they don't need your physical presence. So this is a new update on Unacademy, that is Unacademy Ask a Doubt, where you can post whatever doubt you have, and you have to take a picture of it, have to upload in this platform, and get your solutions in the language that you are preferring in. So it's just like click, crop and submit, and you'll be getting solutions in the your required language. So this is about Unacademy Ask a Doubt. So now coming to the topic. So here, just like previous lectures, we'll be discussing about how to cover the syllabus through questions. This is analog electronics. Previously, we have discussed about power systems and power electronics, and how to cover the topics through questions. That is how this class goes is, I'll take a topic and I'll discuss what are some different types of questions that you might expect in GATE examination from this topic, and you just need to recall the topic and recall the type of problem that I will be telling you now. And you just need to know if you just need to know how I'm going to approach this problem, like what my approach in for this problem will be going to in the exam, and how I'm going to arrive at a solution. So we'll start with diode circuits. So diode circuits is like basic for analog electronics, and also it is basic for even power electronics. So how this diode electronics goes is, first you need to know the basic functionality of diode, and the graphs of forward operation, like conduction and blocking operation. So unlike ECE students who have semiconductor physics and all, we don't have to bother much about this semiconductor physics. Although we'll be covering the semiconductor physics at the end of this discussion. First, we'll look at the most important things with respect to gate examination. That is, first we'll look into the diode circuits. So how the diode circuit is modeled, that is important, and also load line analysis is important. That is how a diode behaves when a source is given and a load is given, how the diode is going to behave, and how the graph of current versus voltage varies. So you have many different configurations, that is series diode configurations and parallel diode configurations. This is more like basic circuit analysis, but here diodes are added, unlike our regular circuits. So there are many things. If only a single diode is given, then the problem is not that complicated. But if two or more diodes are given, the problem tends to be complicated. Then you need to be more careful in solving those problems. So if a single diode is given, now basically what we do is, there are two methods for solving these problems. One is taking the diode as short circuit and taking the diode as open circuit. We can go with either of them, and we'll arrive at correct solution in both of these methods. It is you who has to decide what type of method you are going to use. So you have to be more careful while solving these diodes, circuits having two or more diodes. That is one type of thing. And another is, if it is given in the exam that ideal diode is used, then you have to use voltage drop will be 0. If it is not given, then the voltage drop will be given, that is Vt, threshold voltage will be given to you. So based on that, you have to apply in the examination, but you should not use your prior knowledge in the gate examination. That is, sometimes we are looking at this Vt is equal to 0.6, and sometimes it is 0.4, sometimes it is 0.7, 0.8 and 1. You should not use your knowledge or what is taught in the examination in the classes, or what is taught in semiconductor physics. That is, what are the default values of these VTs. So whatever is given in the examination, you have to take that. You should not use your knowledge or your memory for this voltage drop across diode. So typical problems will be, for 1 mark problems you will be given mostly one diode only, but if the problem is for 2 marks, then you can expect 2 or more problems involving 2 or more diodes. And there are many problems that are in the previous gate examinations, and also you can refer to problems from engineering services examination, gate electrical engineering, and also gate ECE previous problems for this diode problems. That is the problems involving 2 or more diodes. Here one more thing is, you will have a small signal model. Unlike the normal models that we are using, this small signal model is where AC signal is superimposed on DC voltage whatever is given. Here what happens is, the diode equation comes into picture, that is ID is equal to I naught into e power Vd by eta Vt minus 1. Sometimes we tend to approximate this equation, but in the gate examination don't use this approximate formula, because in 2020 gate, I think where people have used this approximation, they have lost their marks. This problem came for 2 marks in 2020 gate electrical engineering. So gate question is more about these exceptions. So where we tend to approximate these formulae, then you will come across the exceptions. So it is better to use the exact formula for this small signal model, and whatever you need to derive and whatever you need to solve, you should try to use this formula and try to get the solution done. So from this small signal analysis, you will also be getting the small signal resistance, or you may call it incremental resistance. So sometimes you may be asked to find out this incremental resistance. It might come for a 1 mark problem. And one more thing is, in the problems involving two or more diodes, sometimes you will be asked to find out incremental resistance. That is, the problem might involve both large signal analysis and small signal analysis. This is one more problem that you might expect in the GATE exam. So the most important use or application of diode is being used as rectifier. So this diode can be used for half wave rectifier, full wave rectifier, and there are many applications. So you have there are this application you will also see in power electronics as well, but the basics come from analog electronics, so you should be perfect in these applications of diodes and bridge rectifiers and everything, so that it will be easier for you in power electronics. So mostly problems will not be asked from these topics for electrical students in GATE examination, because the GATE examiners will be covering this topic in a power electronics subject, so they won't be touching this topic here. But for safety purpose, you should know different types of factors, that is for ripple factor and efficiency and everything. These are just basics, but you need not expect any question from this topic, because mostly the question in the problems you are looking at a circuit given to you and you should be solving the circuit. It's not like they'll be giving any stock questions in GATE examination which are formula based. So you need not bother much about these uh, full wave rectifiers and everything in this topic. And there are some terminologies you should know, that is transformer utilization factor and also peak inverse voltage. Peak inverse voltage is more important with respect to the power electronics subject, but these factors you should know, that is form factor, peak factor and everything. This is important for ECE and also ECE examination and ESE examination, and for ECE students for GATE, but not for electrical engineers. Basically, you should know how this circuit operates, so that if this circuit is added with some other things in the GATE examination and given to you, you should be able to solve this circuit. So center tapped full wave rectifier, bridge rectifier and everything, you should know the operations, and you need not bother much about the utilization factors and all. But basic thing is, you should know the definitions of these factors. Definitions will get you to the solutions, and that's it. And you should not bother much about the filters. This is not important for electrical students, the filters and all. But one thing which is important for electrical engineers is Zener diode regulator. This Zener diode regulator is used as regulation purposes. That is, the unregulated supply will be confined to some particular voltage when a Zener diode is connected in parallel to the load. So what different types of questions you might expect is, you'll be given the minimum and maximum currents through Zener diode, and you will be asked to find out maximum load and minimum load currents, and also value of source resistance or load resistance required for satisfactory voltage regulation. This is standard problem. Even this year, I think there is one question asked from this topic. So you should be well versed with this topic, since there are like three models in this topic, so you should be good at all these topics. So this is about Zener diode. There are other places where you might expect questions from Zener diode is, say you might be given Zener diode with respect to transistors also. These problems you will come across in while you are studying BJTs and all. So what you'll be given is this Zener diode will be connected across the base, and you might be asked to find out the output voltage or the maximum power dissipated across Zener diode and everything. So this is more, again this is more important for ECE students, not that important for electrical students. But it's okay if you are taking a look at these questions in whatever textbook that you are studying in. And one more important topic for electrical engineers is clippers and clampers. So we have three shortcuts for solving these clippers and clampers. So but these questions are important for 1 mark only, that is whatever shortcuts we have, we can use those shortcuts to solve these problems, but those problems will come for 1 mark mostly. That is, if the diode is looking down, then the clamping will be downwards only. There will be 2 to 3 shortcuts for this topic, but they'll be helpful for you in solving only 1 mark questions. But for 2 mark questions, you have to be good at drawing output versus input characteristics. So for this, you need to know input and output, and then how to draw this input versus output graph. That is the transfer characteristics. These transfer characteristics you might expect for 2 marks. So they will involve at least 2 diodes or maybe sometimes 3 diodes, and there are voltages connected to each diode. So based on that, you will be required to draw output versus input voltage forms and everything. And sometimes what you might be asked is, you will be given those transfer characteristics and you will be asked to find out which of the given options represent the volt output versus input characteristics that is given in the problem. So this is one more question that you might expect, one more type of problem that you might expect. And other things are high pass RC circuit and low pass RC circuit and how they behave. These high pass RC circuit, you may call it high pass filter and low pass filters. These filters, the frequency response you can draw from the Laplace analysis of these capacitors and resistors that you can do. And one more question that is asked in previous 2021 gate examination, I guess, that is from this square wave responses of RC filters. That is how the voltage is the ripple of the voltage is given in the examination, and from that you have to find out the capacitance that is connected in series with the filter. This is a typical problem that is not covered regularly in the examinations and everything, but this is a normal problem for EC students. They have already came across these questions in the previous gate examinations, but this type of question is new for electrical engineers. But in this year they have asked this question. As I have said, the gate examination is always about exceptions. They'll be asking the questions that you are not expecting to come in the gate examination. But the good thing is that if you are leaving these topics, then you are not losing much, because these exceptions will count to only 10 marks or 15 marks. If you are targeting at the rest of 85, if you are getting out of out, then you are in good position to score good marks and maybe a rank under 50 or 100. So you need not bother much about these exceptions or most difficult problems that you might expect in the gate examination. But if you have already studied every topic that is given in the gate examination, and also you are taking if you have revised the topics in the gate examination for 2 to 3 times, and also you have given, you are ready to give revision tests and full tests, then you might you are good to take a look at the most difficult questions with respect to electrical engineering coming from analog electronics. You might take a look at ESC solid ESC solid questions, and also ECE previous gate solid questions and everything. But for an electrical engineering, this is not much important. Sometimes questions might appear from gate examination from these topics, but not much important. If you have less time and you are willing to cover all the topics, then you can skip this topic. So now coming to clamper, this also has some shortcuts where you can draw the waveform of clamped waveform at the output by looking at how this diode is positioned. And even here you have this no, all these exceptions will happen because of capacitor only, because in the assumption we think that capacitor discharges fastly through the resistance, or capacitor does not discharge through the resistance at all. So there are 2 different cases, but in reality what happens is the capacitor discharges slowly, so that the output waveform is not straight, it is linear. That is, it will take y is equal to mx plus c graph with c not equal to 0. So that's why the exceptions are coming, but these exceptional cases need not be taken seriously. Voltage doublers, this is again important for gate examination. That is, sometimes you will be given a voltage doubler, or sometimes you will be given voltage tripler, voltage quadrupler. So you might be asked to find out. You won't be given in the exam that it is voltage doubler. You will be simply given a circuit. So depending on the number of diode and capacitor combinations, you should be able to tell whether if it's a tripler or a quadrupler or a voltage doubler. So this you need to know. And also one more thing is, you should know the voltage across each terminal. That is not only the output voltage, but also the voltage across each terminal, so that gate will check your fundamentals. So it's not always about the output voltage. You should also be able to tell the intermediate voltages also. So this is about this diode circuits and all. So now we'll look into BJTs and biasing techniques and everything. So we all know that BJT has four modes, that is cutoff, active, saturation, and reverse active, and also different components of BJT will be there, and also you have emitter efficiency, current signal gain, alpha, beta, and gamma. But the thing is here, the alpha, what we see is an approximation, it's not exact one. So for exact one you have to consider IC naught also, but in the majority of cases we are neglecting this IC naught. So this is again one exception here. So you should be also good at this exception, so that you'll never know, this might be tested once on gate examination. And what different components of say we have a collector, base, and emitter. So collector will have two components, base will have two components, and emitter will have two components. Out of all these components, what components are contributing to collector current, and what components are contributing to emitter current, and what are contributing to IPE, INE, and everything. These you should know, so that you can segregate these. If it is given in the examination, you will be able to segregate these things. So, and again, one more important thing is a base emitter shorting. So when base emitter are shorted, or otherwise not base emitter, that is collector base, if when collector and base or any two terminals of a BJT is shorted, any two consecutive terminals are shorted, then it acts as diode. So in that case you will be required to apply diode current equation, that is I is equal to I naught e power Vd by eta Vt minus 1. This is one thing. And another thing is early effect. Early effect is not that important with respect to gate examination, so you can leave this. And also there are different configurations, that is common base, common emitter, and common collector configurations. You need not know about all these configurations, because in the gate examination what happens is you will be given directly a circuit, and you will be asked to find out whether it is in forward mode or cutoff mode or saturation mode. And sometimes you will be asked to find out what is the emitter current, and what is the load current, if any load is connected across collector or emitter. So it's mostly about the circuit analysis in the gate examination. And there is one thing, that is a stability factor. This stability factor, what we are used to is, we are used to one formula, that is 1 plus beta by 1 minus beta into dou IB by dou IC. So if you know this formula, then you can apply this formula in the gate examination to solve the problems. And now coming to BJT biasing, there are many different biasings, that is fixed bias circuit, collector to base bias circuit, and self bias circuit. So you need not know how the circuit diagrams of each type of these biasing circuits, that is fixed, collector to base bias, and self bias, but you should know how to solve this different types of circuits if it is given in the examination. So it's more about the solving of solving these circuits if it is given, if they are given in the examination. It's not about remembering these circuit diagrams. So these three different types of biasings will have three stability factors. So you need not know about stability factors for these three, but a basic formula for stability factor should be known. And this stability factor can be derived from two KVLs, one in the input and one at the output. So based on that, you will get the stability factor. And this self bias is also called voltage divider bias. This is more important for gate examination because students tend to commit mistake in this type of biasing. This is the most stable biasing and also most tested biasing in the gate examination. So we'll be using a Thevenin equivalent in self-biasing circuits. So whatever collector VCC is given, that will be divided using the voltage divider technique, and then you can solve the problem just like any other problem. So sometimes what we'll do is we'll assume that the given BJT is operating in active region, then we'll find out V collector and V base and V emitter, and based on the values we'll try to see if it is in saturation region or active region. If it is coming that VC is greater than VB for NPN transistor, then it can be treated as forward active. If it is saturation, if it is not the case, then it might be under saturation condition. So for saturation, then again you have to change the value of beta, and then again you have to calculate everything. That is one thing. And there are different compensations for bias compensations for BJTs. These compensation techniques you need not know, and also the circuit diagrams you need not know. What you need to know is how the circuit operates, how to solve the circuit diagram if it is given in the examination. Thermal runaway, it is not important for gate examination. And Bjt biasing in ICs, constant current mirror is again important for gate examination. You should know how to solve the circuit with the approximations will be given in the gate examination. Unless it is specifically mentioned, you should take approximations in gate examination. If there is any value you should consider, it will be given in the exam. Otherwise, you should approximate this. Current mirror, again you need not remember the circuit diagram of current mirror. You should know only how to solve this current mirror circuit. This is one of the most important topics for gate examination in electrical engineering and also ECE exam. So current mirror you should know how to solve. What happens in current mirror is the collector currents are same, and also the betas will be same. If it is given in the exam that both transistors are identical, then collector current and beta you will take same, and then you will find out the rest of the things that is asked in the examination. And there is one more thing, that is Widler current source. So this is an extension of this current mirror. Again you need not remember the circuit diagram for this current source of BJT. You should know how to solve the problem, which will be more than enough. And also other things being current repeaters, that is you will have one biasing circuits and circuit, and from that you will be having same repeaters of BJT, where you will be having collector currents, and these transistors are connected in parallel. These are again used to represent source currents, and this is also important model where you will find out the total collector current, or also total reference current and everything that you might be asked to find out. And there is one more thing, that is Wilson current source. These names are just different, and the circuit diagrams are difficult to remember, but what you should know is how to solve the circuits, which is more important than remembering the names of the circuits and also remembering circuit diagrams. The most important thing is the ability to solve the problem. So whatever circuit diagram is given in the examination, you should be able to solve the circuit. You should be able to arrive at a solution. This is more important than remembering the names of whatever the current sources or mirror circuits, current mirror circuits that I have told you. you should know you should know how to solve whatever current sources or current mirrors that I have told you till now. That is, one is current mirror, which is straight one that we have already seen in gate examination, and other one is a Weidler current source, and then comes current repeaters. All these circuits you should know, and also there is one more thing, that is Wilson current source. These current sources are in gate examination perspective, these are more important for problem solving. uh, in masters you will be having applications for these current sources, but as long as gate examination is concerned, you should know about how to solve these problems. That is, how to solve the topics or circuits that is given in the examination. Now comes BJT as an amplifier. How to model this BJT as amplifier? Mostly will be using H parameters. So these H parameters are important for ESC examination, but for gate examination, that too for electrical engineering, this is not much important. These parameters and all, you should know hybrid pi method will be sufficient, which is more easier. And also sometimes we are taught about this hybrid pi circuit with early effect included, but early effect is not important for gate examination. So we are taught 2 to 3 models for this small signal analysis of BJT. So take any of these models, and then you are good to go, and you are good to solve these problems. But important thing is, you should know the relation between GM, R pi and RE. So if you know the relation between these three, then if one of these three is given in the examination, then you will be able to solve, or you should be able to convert the given parameter into your known parameter, and then you can draw the circuit that is more familiar to you, and then arrive at solution. You can solve the problem based on that. So that is about finding these things, and early effect consideration is not that important. So mostly we are asked in the gate examination, the topic that is most important for gate examination is common emitter amplifier. So which will be having more gain than the rest of two amplifiers, that is common collector and common base. So an input will be given, and all the resistances of the circuit will be given to you, and you are you will be asked to find out a small signal voltage gain. So based on all these values, you can find out these the whatever gain that is asked. But sometimes what happens is, you will not be given RE or GM or R pi. So you should find that value from the DC values that is given in the exam question. That is, you should be able to apply DC analysis from whatever biasing voltage that is given. You should be able to apply that DC analysis, and you should be able to solve this problem for gain. And other thing is, sometimes you will be having a bypass capacitor, and sometimes you will not be having any bypass capacitor. So if any bypass capacitor is given, then the DC analysis will change, because that will be behaving as circuit behavior will change if the emitter is having a capacitor, and if it's not having any capacitor. You should also pay attention to this detail of the problem as well. That is, we have seen about a common emitter. Now coming to common collector, the modes will change, but the method of finding or solving the problem will not change. The circuit will change only. This common emitter, this will have again less voltage gain. It's also called emitter follower, because the voltage gain is almost equal to 1. So you need not know about the approximate values of the voltage gains. But if the circuit is common collector, then the gain is almost equal to 1. So if it is asked in the examination, or you are having trouble with 4 options, and if 2 options are near to 1 and other 2 options are very much greater than 1, so based on the type of circuit, that is common collector, if it is common collector, then you are left with only 2 options, that therefore you can eliminate other 2 options. So it is more important to remember the input impedances, output impedances, and gains, current gains and voltage gains. It's not like remembering them, but you should know about the range of values for which the gains can vary, and the input and output impedances can vary. And then you have a common base amplifier. So for all these amplifiers, you need not remember the formula for voltage gain and everything. You should know how to solve the problem, because in the examination there will be so many approximations, so that you can arrive at final answer easily. Since these are solving the circuit, if it is given in the examination, will take more than 5 to 10 minutes. So there will be so many approximations that will be given in the exam. So if you are prepared to solve the circuit in the exam, you will be having sufficient time. You need not remember all these formulae, because there are so many exceptions and so many formulae for different circuits. If you know how to solve the circuit, then it will be more than enough for you in the examination for solving these problems. And along with voltage gain and current gains, you might be asked to find out input and output impedances. Again, this comes under solving the circuit. And you have a Darlington pair configuration. This is when the BJTs are connected in a cascading, or you can call it is one of those multi-stage amplifiers. This you will call cascading configuration, and other is cascoding. So the basic thing is you should know how to solve these circuits. What are the approximations that are taken? So whatever circuit you have in your class notes, you try to take it on a white paper, and then you try to solve it for voltage gains and current gains and everything. And then if that question is given in the examination, it will be easier for you to solve the problems. So this is about BJTs. And in the coming lecture, we'll look at FET amplifiers and oscillators and active filters and everything. So in this lecture, till now what we have discussed is diode circuits, that is clippers, clampers, and half wave rectifiers, full wave rectifiers, and what are different things that you should keep in mind when going for the exam, and also Bjt biasing and Bjt as an amplifier. Thank you.